In Lesson 5-7, we're looking at scatter plots and lines of fit. We'll interpret points on a scatter plot and write equations for lines of fit. How do scatter plots help identify trends in data? The points of a set of real-world data do not always lie exactly on one line, but you may be able to draw a line that seems to be close to all of the points. The line in the graph shows a linear relationship between the year X and the number of bushels of apples Y. As the years increase, the number of bushels of apples Y increases as well. A scatter plot is a graph in which two sets of data are plotted as ordered pairs in a coordinate plane. Scatter plots are used to investigate a relationship between two quantities. In the first graph, there is a positive correlation between X and Y. That is, as X increases, Y increases. In the second graph, there is a negative correlation between X and Y. That is, as X increases, Y decreases. And in the third graph, there is no correlation between X and Y. That is, X and Y are not related. Looks like snowflakes or raindrops, something like that. Determine whether the graph of personal income for U.S. citizens shows a positive correlation, negative correlation, or no correlation. If there is a positive or negative correlation, describe it. Well, it sure looks like it's going up. Not real fast, but still it's going up. So that would be a positive correlation. And then we're supposed to describe it. So we could say with each year, the average personal income rose or increased, something like that. Same question, determine whether the graph shows a positive correlation, negative correlation, no correlation. If there is a positive or negative correlation, describe it. Well, this is definitely going down, so that is a negative correlation. We could say with each year, more computers are in the schools, making the students per computer rate smaller. Now, at some point, we're going to have enough computers. That's not going to continue indefinitely, but in this snapshot of time, it works. Okay, I pulled in one more. I'm calling this example 1C. We did one with a positive correlation, one with a negative correlation. So this looks like, well, if you drew a line this way, it could be a negative correlation. Or maybe you could draw a line this way and call it a positive correlation. So guess what? That is a no correlation. Oh, look, it looks like an X. No correlation. If the data points do not all lie on a line but are close to a line, you can draw a line of fit. Oh, that's what I was trying to draw. This line describes the trend of the data. Once you have a line of fit, you can find an equation of the line. The table shows the world population growing at a rapid rate. They want us to draw a scatter plot and determine what relationship exists, if any, in the data. Now, really, the toughest part of making a scatter plot is getting a good scale. They did a good vertical scale here. They're going up by thousands. I have an argument with their horizontal scale because they did the 1, 2, skip a few and didn't put in an interrupter. Okay, so now after that, they're going by hundreds, and it's okay now that we added that little interruption. So they plotted the points from the chart. I think you guys can handle that if we give you the graph paper. Now, the tricky part is, how do we draw a line that matches these points? Now, a good line of fit is going to have about half of the points on either side. They don't necessarily go through the points, but I could say if I go through these two, it puts one quite a ways on the left. These two are a little bit on the right. It's a fairly good line of fit. Now, we drew our line of fit kind of through the points 1851,000, and that's in millions, so that would actually be 1 billion. And 1998 looks like 5,900. So to write a slope-intercept form of an equation for the line of fit, this is when you're going to want a calculator to find the slope formula. Slope is change in y over change in x still, but our numbers are larger. So we could do our change in y, 5,900 minus 1,000 over change in x, 1998 is the, and the number that went with the 1,000, the year was 1850. So we get change in y of 4,900, and yes, I make cursive zeros, over change in x is 148, and so we get about 33.1 with some rounding. I'm going to go ahead and use our point slope form. Since we have a point and we have a slope, we could also use slope intercept form, but I'm kind of liking this one. Y minus 1,000 equals, the slope we found was 33.1 times x minus 1850. And yes, we're going to want a calculator for our arithmetic on this one. So we're going to have y minus 1,000 equals 33.1x minus 61,235. We add 1,000 to both sides, we get y equals 33.1x minus 60,235. Now, as a check, we could take our other point that we didn't use in our point slope form that we used to find the slope and see if we substitute it back in if we get a reasonably close answer. So I'm trying to get 5,900. If I substitute 1998 in for x, and using a calculator, because we would take all day and all night doing this by hand, we're trying to get 5,900, and we'd settle for close because we did round when we made our slope, and we're trying to get a line of fit that's close. And the calculator gives us 5,898.8, which is pretty darn close. We could live with that. Now, the reason we'd like to find equations for lines of fit and lines of fit in general is so we can make predictions. Clear back in lesson 5.4, seems like a long time ago, you learned about linear extrapolation, which is predicting values that are outside the range of data. You can also use a linear equation to predict values inside the range of data. This is called linear interpolation and is more reliable because we know what's happening on either side of it. So now they want us to take that prediction equation we just made, which if you pick different points, you may have gotten a different equation, where x is the year and y is the population in millions, to predict the world population in 2010. So it's a function, so where there was an x, we're going to replace it with 2010 and see what we get. And typing that into the calculator, we get 6,296, but remember that was in millions, so we need to fix that. It would actually be, that's millions, so I need 1, 2, 3, 4, 5, 6 zeros after that. In summary, if y increases as x increases, there is a positive correlation between x and y. If y decreases as x increases, there's a negative correlation between x and y. If there is no relationship between x and y, there is no correlation between x and y. A line of fit describes the trend of the data, and you can use the equation of a line of fit to make predictions about the data. Either it's a positive correlation, negative correlation, no correlation, you can't predict much at all.